I think, but now the record holder is bacteria called Vibrio nitrogens, which can double itself every 6 minutes or so. So this raises a lot of really interesting questions. Similar questions to what I was interested in with respect to tip growth. But how are these incredibly fast growth rates controlled? How is stability guaranteed in cells that grow so fast? What are the physical forces as well as the biochemical factors that are required to drive growth at these incredible rates? And this group of problems is broadly what my group is interested in. So the very broad way to put the question is what is the organization of the systems by which single cells control their growth rate? But proliferation includes not just growth, but also requires division. It requires survival of complex environments. And I'm going to talk about how growth is also connected to morphogenesis, or the process by which cells control their shape. So as I mentioned, these are sort of sub-questions. One of them is how do cells generate and harness forces in order to drive growth at these incredibly fast rates? More recently, I've become interested in understanding physical factors like mechanical forces and electrical fields as signals. So I'm sort of distinguishing, at least in the case of mechanical forces, as using them as something to drive deformation or movement of material, and using them as information as parts of feedback systems. And one of the simplest questions to phrase, but one that turns out to be very interesting and profound with respect to physiology, is simply what are the mechanical properties of cells, or their subcellular components, and why do the cells care what their mechanical properties are? So what's the adaptive value of these properties?